Hi everyone, so in this video we're going to be looking at the properties of covalent compounds, more specifically simple covalent compounds, and we'll be looking at the volatility, solubility, electrical conductivity, and melting point and boiling point of simple covalent compounds. Let's watch this video.
Non-metals can join together by covalent bonds, in which they share electrons so that all of the atoms have full outer shells. Sometimes this results in small molecules, such as chlorine or ammonia, and we call these simple molecular substances. In other cases though, non-metals bond covalently to form giant covalent structures, like diamond, graphite, or silicon dioxide. And in today's video, we're going to look at the respective properties of each of these, and then finish up by taking a closer look at the structure of silicon dioxide. Now, the first thing to know is that covalent bonds are really strong, which means that a lot of energy is going to be needed to break apart any atoms that are covalently bonded to each other. So if we consider a simple molecular substance like chlorine, the atoms within each molecule will be strongly bonded together. However, in order to melt or boil chlorine, we actually don't break these strong covalent bonds. Instead, we only need to break the weak forces that exist between different molecules, which we call intermolecular forces. Because of this, we only need very low temperatures to melt or boil simple molecular substances. For example, chlorine boils at -34 degrees Celsius. Although these intermolecular forces are individually quite weak, the more of them that a molecule has, the stronger the overall attraction is going to be. For example, let's compare the halogens, chlorine, bromine, and iodine. Because we're going down the group, the atoms and thus molecules are getting bigger, so there'll be more intermolecular forces between them. This in turn means that more energy will be required to break them all, so the melting and boiling points should increase as you go down the group, which they do, as bromine has a boiling point of 59 degrees, and iodine doesn't boil until 184 degrees. There's no need to remember these specific numbers. You just need to understand that the boiling point increases as you go down the group because the molecules get larger, so there are more intermolecular forces between them. Another property to note is that simple molecular substances don't conduct electricity, because there are no free electrons, and the molecules themselves have no electric charge. You'll see this point again and again in chemistry. In order to conduct electricity or heat, substances have to have some electrons or ions that are free to move about. So moving on to giant covalent.
So let's see the forces of attraction in simple covalent compounds. So the interactions between the molecules are called van der Waals forces. This is what was referred to as the intermolecular forces. So there's two kinds of attractions actually. There is intramolecular. Intra means which is inside the molecule. So this is a molecule of chlorine gas. So inside the molecule there is covalent bonds which are very strong, and between the molecules there are very weak interactions, weak intermolecular forces between the molecules. These are called van der Waals forces, and these interactions can be easily broken. And when we are melting or boiling chlorine, the substance chlorine, we are actually breaking these weak intermolecular interactions, these weak forces. So this is why simple covalent compounds have low melting point and low boiling point, because a very small amount of energy is enough to break the weak intermolecular forces. So if you have to show the covalent bonds in the iodine molecule, this is what will be the covalent bond. So inside you have the covalent bond here, that's the covalent bonds, and in between the molecules in between 2 or 3 molecules, you will have the van der Waals forces. So there is 2 kinds of interactions here. There is an interaction inside the molecule, which is the covalent bond here, inside the molecule over here, that's the covalent bond, and in between the molecule is the weak van der Waals forces. Now, the van der Waals forces, they are due to the presence of electrons, and the more electrons are present, the stronger that will be the van der Waals forces. So like you saw in the video, as we go down the group 7, so you'll see down the group 7, the number of electrons is increasing. So if you have more electrons, this means that there's going to be more van der Waals forces. This is why down the group 7, you have higher melting point. So fluorine forms F2 molecules, covalently bonded. Cl forms Cl2, Br forms Br2, I forms I2. These are diatomic molecules, which means that in these diatomic molecules there's going to be covalent bonds inside the molecule, but in between the molecules there's going to be weak van der Waals forces, and as you go down the group, the strength of the van der Waals forces increases. This means higher melting point or boiling point as you're going down the group 7 elements. Okay, so let's continue. So the force of attraction between anions and cations in ionic bond is called electrostatic forces. So anions are negative, cations are positive. It's called electrostatic forces, and these forces are much stronger than those present in simple covalent molecules. And in simple covalent molecules, you have the van der Waals forces. Right. Now describe the difference between melting point of ionic compounds and simple covalent compounds. So in ionic compound, there is strong electrostatic forces, which is going to require a large amount of energy, but in simple covalent compounds, you have weak van der Waals forces, which require small amount of energy. So I'm pretty sure you can describe the difference, and here you have to explain the difference. This question, all group 7 exist as diatomic molecules, and you have to explain why the boiling point of the molecules increase down the group. Let's look at the physical properties of simple covalent compounds. Now, simple covalent compounds are like H2, Cl2, Br2, CO2. All the examples that we did, the dot and cross diagrams, are simple covalent compounds. So all these are simple covalent compounds, and the melting point depends on the intermolecular force of attraction, and the force of attraction between simple covalent compounds are called van der Waals forces. And it is a weak force of attraction. So what can you say about the melting point or boiling point of covalent compounds? I'll let you answer this. Electrical conductivity depends on the presence of mobile charges, that is either mobile ions or free electrons. Now, in ionic compounds, you have mobile ions when they are either dissolved in water or when they are molten. But in covalent compounds, there is no ions over here. There is no charged particle. Electrons are trapped in the electron shells, and there is no cation or no anion, which is 4. So there is no mobile ions, there is no free electrons. So explain why it does not conduct electricity in any state. So either the covalent compound is dissolved in water, either it's molten, either it's solid, liquid, gas, it will not conduct electricity. So explain why. I leave that up to you. Solubility in water depends on the presence of charged particles again, because water is going to be able to be attracted to these charged particles. So can you comment on the solubility of covalent compounds in water? So you just have to say whether it's soluble in water or not. and hence you're going to state the three properties of covalent compound in terms of melting point, in terms of solubility, in terms of electrical conductivity, and in terms of solubility. So that's the three properties. You will also have to compare the properties of ionic and covalent compounds. So melting point, boiling point, so here you'll have to say if it's high or if it's low. Volatility is something that has a low melting point, low boiling point will be highly volatile, and something that has a high melting point, high boiling point will have low volatility. Volatility means its ability to evaporate in air and to form gaseous substances. So I'll let you fill that in. Conductivity in solid state. So then you'll have to say if it conducts in the solid state, if it conducts in the liquid state, or dissolved in water. So here is just a yes/no question. Solubility in water, again it's a yes/no question, if it dissolves in water or it doesn't dissolve in water. So that will be it for this video. I leave you the worksheet that you'll have to complete.